Hey everyone, today we're going to take my Westinghouse iPro 4200 and convert it to natural gas, connecting it to my home gas line. Before undertaking this project, there were a couple things I wanted to do first. Number one was cleaning out the carburetor. This is especially important if you've had gas rot in there or you believe that your gas has gone bad. It'll save you a lot of trouble. Link to this video is provided in the top right. Another project I wanted to do before I began this was the Wen wheel kit direct bolt-on for the iPro 4200. Very strange indeed, but it does work. So another link, top right, will take you to that. With that out of the way, let's get started. There's a ton of different kits being sold online. This is just an example from eBay doing a quick search. These are ranging from $150 to $250. There are also some really cheap complete carb replacements available on Amazon as well. These are exact model drop-ins. You better have room in your frame to support this setup. I opted to pay a little extra for companies that actually specialize in this service, so I googled generator natural gas conversion online, and I went down the list one after the other. The websites, absolutely dreadful or broken and didn't work right. Their database is broken, so I reached out to them via email. Most of them weren't bothered to deal with me if the generators weren't explicitly supported, but there was one company in particular. Their customer service was wonderful. So I reached out to them, we had a dialogue back and forth, and I ultimately ended up buying their kit. And the company was Century Fuel Products. I reached out to them with my situation. I wasn't getting any help. They had researched my generator and found a product that would fit mine. They also asked me to take a look at how much pounds of pressure my gas was coming into the house, and they had sent out a regulator for that value. I am not receiving any discount from them. This is not a paid promotion. I'm simply reviewing the installation of this product from them. They were very helpful, so we're going to see how well the product from them works. I want to stress that when they said that this kit would fit, that means to the carburetor. This particular generator is a very strange design, and I imagine that there's going to be a lot of modifications to get this kit to fit nicely to this generator. So we're going to see what happens. I just wanted to point that out specifically. It has arrived. Let's do an unboxing. A regulator, a box of stuff to be opened, bag of various things, a small length of hose, and an instruction manual. The instruction manual is well written and highly detailed with lots of pictures. We'll be using this a lot throughout the video. Now I'll begin the installation. First order of business, we're going to make sure that gas valve is turned off. Bring that carb bowl drain hose around. Drop it into a clean jar. Open up the bowl drain screw and let the bowl empty out into the jar. When it's empty, just close that screw right back up. Once the screw is closed, that fuel that's in the jar could simply be dumped right back into the tank and reused. It says the spark plug gap should be dropped from 35 thou to 25 thou. I don't know what mine is, so I'll investigate. So we'll pop the cable off right over here. This is a standard spark plug socket to be sure, in 13/16. But the shield, the one that says OHV on it, sticks out just a little bit over the hole for the spark plug. It's a really bad design. So there's a little bit of rubbing on that socket, so I just have to work it in a little. Just bad design. I'm very shocked that this was designed this way. Be that as it may. Wasn't really dirty, but I hit it with a brush. We're looking at about 30 thousandths. We're going to knock off 5 thousandths from it. Gently stressed it in on a flat stainless surface, and now we're walking it out to 25 thousandths. Looks good, about right there. Take one final measurement, shows 25 thousandths on the money. We're going to go with that. We're going to pop it right back in the motor. Always hand turn spark plugs to full seat. Only use a ratchet to tighten. Doing this helps avoid cross threading. Drop the wire back on, and that task is done. Next piece we're going to be working with, they call the adapter. It has threads on the bottom we're going to be fitting a 90-degree elbow into. They supplied PTFE paste, but the book calls out the tape that I generally use. So I'm going to use the tape because I have it. Here's that 90-degree elbow. So 2 wraps of Teflon tape on the fitting, then hand tighten it in. Did one final turn with the 12 mil. Make sure it's nice and tight, pointed in the direction it'll be facing outward. They supplied hose clamps for the next step. And I could already see there's a problem here because when I put the hose clamp on and then I put the hose on the barbed fitting and I try and tighten down this clamp, it's just too small. You can't get any of those teeth through the windings to get a bite on it. It's just not going to work. It sits right on the edge. It's just too small. Instead, I'll be using my own clamps for this job, notably bigger than the one supplied for reference. And that clamp down, no problem at all. Move on to the next step. Everything about the next couple steps does not apply to my generator because it's different until we get right to here, and that's where the action continues. Mine has a manifold that sits here forward the carburetor with a pipe that goes down, and this is actually my air filter box below. We're going to move this manifold. Here's the choke. Here's some hoses that need to be removed. First, I'll pull off this crank ventilation hose. This clip right here holds it on. Pop the hose right off. Also have this fuel vapor line right here. I'm going to remove from the manifold really quick. Now we remove the 10 mil nuts that secure the manifold. I need to loosen this air pipe too. Slide it out of the way. We'll slide the manifold right off, but we'll be sure to leave the gasket behind it on the stud. Push that out of the way. You can see that gasket will push everything back in position. I have 2 sets of stud extensions, these, and a bigger set in the bag. I believe the small one's going to fit. I'm going to try them first. So I'm just going to screw them right on over the gasket just like that. The adapter goes right over the stud extension, fits very nicely. Place it to full seat, noting the direction of the arrow. The provided gasket is then placed over the studs. As I place the manifold on, I realize I run into my first problem, and that has to do with the choke. The choke is actually mounted on a bracket on the manifold. It will no longer fit on there and on the choke plate, so I'm going to have to remove it and deal with the choke as a separate issue. The choke screw and bushing is removed from the manifold. I pull the screw out by hand. The bushing sits on the bottom. That's what allows it to swivel even when the screws tighten down. With that separated, the manifold can now be placed over the studs, fully seated. We'll just have to make a solution for the choke later. We can put the nuts back on the top. As we go to put the air hose back on, we run into our second problem with this installation. Since the manifold's been pushed out slightly by this installation addition, we're going to have to bring the air filter out ever so slightly by a couple of millimeters. We'll start by removing the air filter cover, followed by the filter itself. This reveals 3 bolts inside the housing that hold the housing to the chassis of the generator. The method I used was placing a nut onto the screw, but on the back of the filter housing, thereby moving the filter housing a bit outward from the chassis. I'll demonstrate how this was done using this nut, but I'll tell you right now, the one nut was insufficient, and I ended up having to use several. The problem was the original screw was too short, so what I ended up doing was having to use 3, and with that, a longer screw. But ultimately, this was the method that I used, placing it back in. The housing moved more forward and outward from the unit. We now reinstall the air filter pipe onto the manifold. And we can see that it fits with absolutely no problem. So now we'll drop in the filter. We'll place on the cover. Screw everything back on. That'll be the end of the filter modification. We just have to tighten down these 2 hose clamps right here that hold that pipe on. Perfect modification. Everything looks factory. We're going to move on to the next step now. The choke is a bit trickier. I've pulled the pin out of the bottom here. I'm going to see what I could get away with as far as the fulcrum of this thing. It's a really cheap setup. I'm going to be using a rivet as the replacement. I'm going to pop the rivet to extract the stud in the middle. I'll line it up with the original one to get my first bend. So I got that linkage done. Now I just need to stop that pivot. Make sure the fulcrum's good enough so it deflects all the way. Or evenly. I might need to make an adjustment. But you can see if I hold it like this, that works just fine. Let's see what we can do. For this, I'm going to try using some 2-part epoxy, which I'm going to mix up and put in the hole where that new linkage will go. The epoxy has been applied into the hole as well as here on the linkage. I'll assemble everything back together in a position and leave it there to cure. While that's drying, I'll start reconnecting the hoses to the manifold. There's the emissions hose. Now just slide that clamp back over. It's no surprise that the crank ventilation hose is now too short. I'm going to have to make a modification to make it slightly longer. I happen to have a slightly larger piece of crank ventilation hose. The original line is cut and then wedged on both sides. It makes a tight fit, thus producing a longer hose. We try a test fit now. Everything looks good. Everything fits. So we'll just drop the clamp on and we should be finished with this issue. I think this concludes all the weird idiosyncrasies found in this one-off generator for this natural gas install. We're going to put the regulator right around over here. Make sure nothing's behind there. We're going to line it around the sticker. We're going to be able to level it as well as mark the location with a pen. So I'm going to do that now. Right there at the edge. This gives also enough clearance to reach the carburetor for any carburetor work that needs to be done without removing this. We peen the holes for the pilot. And I already learned from the last project this is really tough metal, so I'm using progressively larger bits to drill out all the way to 1/4 inch, which is the size for these bolts. Quick test confirms that I didn't screw anything up. Our first piece to bolt onto the regulator looks a little bit different than shown in the manual, but no matter. It connects to the regulator as shown. Teflon tape is used at every connection. A wrench finishes each part off exactly into its final position. Open up another bag of stuff where I follow the instructions using more Teflon tape, making more connections to build out these pieces exactly like the diagram specifies. As I try the fit, I realize the bolts are too long. I'm going to have to use shorter bolts. Also, I'm going to have to temporarily remove this charcoal canister to gain access to the back of the bolt to put the nut on. With that piece removed and the smaller bolts being used, tightening up both sides was no problem at all. Now put the charcoal canister back into position, screw everything back down, and then tighten it back up. Pick a length for our hose size. Try to get a good bend, but not too much. Once the cut is made, the hose will go over the bob fitting with a hose clamp. And that hose clamp will then be tightened down as we then make our way to the other side of the regulator. This piece is assembled from a bunch of different fittings that allows for a quick disconnect. Here's a coupler right here that I'll add to it. And we're going to start from that coupler and work our way out from the regulator. With that, the generator portion of the work is completed. Here's a mock-up of the parts to be installed outside. I got a coupler going to a T. That T extends to the barbecue pipe. Going down, I have a shut-off valve. That's for the generator. And that extends all the way outward to this quick release on the bottom. That'll be going to a hose to be built that will go to our generator. Here's a connection going into the house and off to the barbecue. We'll put in a coupler that'll allow us to add a generator to the mix while supporting the barbecue as well. First thing we're going to do is remove the barbecue fittings and associated hardware. That includes this 90-degree bend. We'll replace it with a coupler, followed by a T-fitting that we're going to set up to point downward. On the end of this, we're going to put that barbecue's 90-degree fitting back on. And then we'll reconnect the barbecue line. After this, we'll insert a coupler into the T-fitting, followed by the gas valve. We'll set up the gas valve to point in a convenient location facing forward. At this point, we can take a moment to test all the fittings that I made, make sure there's no gas leaks. We can see that I have the valve shut off. I'm going to turn the gas main back on, and we're going to check out and see if there are any bubbles using a water soap mixture. This is a very heavy mixture of dishwashing detergent and water, and I'm going to apply it to all the fittings around the Teflon tape. If there's any gas leaks, it should start bubbling up. It should be very noticeable. If there is, I'm going to go over some of the old connections around here too, just to check while I'm here, but those should be fine. And in checking, I did not find any leaks. Also check for the presence of gas smell, and didn't find any of that either. I shut the gas main off and continue with the addition of this coupler. After which a few reducer fittings are then added. On the supply side, I'll be using the female fitting for an added safety. Should the hose become disconnected with the valve on, fuel will stop flowing. So that's the final layout. We got our main feed into the house, then we got the generator, then off to the barbecue. The generator has the valve, and then of course the quick release valve. The gas main is back on, and you could see as I open the valve, nothing happens because we have that female connector on this side. It's blocking the flow of gas. If there's no fitting connected, there's no gas smell, everything is contained. You would generally never leave this valve on. It's just a safety precaution, but that's why I would never put the other type of fitting on there. It would be absolutely terrible if a hose disconnected. Furthermore, for added safety, I have a special type of device that goes over the valve to secure it so it can't be turned. It is secured with a lock. It goes over here on the left-hand side. That way nobody could just walk up and turn it. Picked up all the pieces I would need for my custom hose at Lowe's. Even saw a little inspiration for a dual generator adapter. So we'll start assembly now. This would be a hose clamp followed by a bob fitting. Tighten it down. The supply side will receive a male connector. Generator side has the female connector. With that, the hose assembly is now finished. Connections would simply be to plug in, turn on the gas valve. Shutting off the generator would be by the valve, and then disconnect the hose. Before we get underway, I have no more use for gasoline in this generator, so I pull off the main gas line. I'll be bringing around a clean, empty gas can. I've put an extension on this hose so it fits in the can. Drop it in, open up the valve, and just let all the gas flow into it. As I got towards the end, I propped up the other side of the generator and had the remaining gasoline pour into a glass jar, threw that in the gas tank. And that was it. Generator's completely clear of gas. Put the hose back and we'll move on to the next step. So I'll connect the hose to the generator first, then to the quick release of the gas line, ensuring everything is properly connected. Then I'll turn on the gas line, then this gas valve. There's a priming button in the back of the regulator that's used to assist in starting the generator. It also helps to push out the air that's in the lines of the hose. I hit that for a second or so, Push the choke all the way in. We won't be using that with natural gas. Make sure that the power button is set to on for ignition. Give it a pull or two, and there we go. You can hear that it's running like crap because we have to set the mixture. So I'll go around here. There's a mixture screw, and you'll see quite clearly I've loosened the nut to allow the screw to have easy adjustment. As I set the screw to just the right spot, you'll hear that engine just smooth out perfectly. Right here you could hear it falling into an ideal mixture condition or very close to it. Ideally you'd want to set this under load, but for now it represents a good demonstration of this setup. The panel indications show everything operational. I've seen about 123 volts at the sockets. So let's run a load test, see what we can do. This heat gun is good for about 30-35% of the total load. We'll try it out. So now with the heat gun running again under load, I'm going to go around and I'm going to adjust that screw as an example. I probably want some more stuff running on here to do the final adjustment, but you can see now that it's running under load, the characteristics are different. So I loosen that nut and I'll just be making an adjustment. I could hear it in the exhaust on this particular generator when I get that final minute adjustment that gets it just right, and that's what I'm listening for. I don't know if it comes out in the camera as good as it does here, but now I got it just right. It sounds good. Comes off and it takes a minute to catch up, the governor, but it works very nicely. At least at 1500 watts. I'll be adding more loads to it as I test it out in further testing. Another thing I wanted to test in this inverter generator is economy mode. You can see it does run under economy mode as well. And then we'll put it under load from economy mode. Yeah, that ran with no problem at all. I'm surprised. I was concerned that there might be some issues, but it seems to be doing okay even with that function. And that concludes this natural gas conversion of this Westinghouse iPro 4200 using the Sentry kit. Turned out pretty good, I think so. Hit that like and subscribe button down below to let you know more videos come out. It helps me out a lot when you do. Again, I hope you enjoyed this video.
Thanks for watching. Can I get in there?
Thanks for watching. Would you like to reply?